Okay, hello. This is video number 18. This is chapter 4, section 2, and it is all about solving a 2x2 system of equations. Remember, a 2x2 means x and y, so it's a linear system, and we're solving by substitution. Which means that we're going to take one equation and plug it into the other one. Super quick review. Remember, you can have 3 outcomes to these types. We graphed last time and saw that those 3 outcomes can give you one solution, and that was the intersection point. You can have an infinite number of solutions if you have the same line graphed twice right on top of each other, and you can have no solution if you had a set of parallel lines, because they would never intersect. And we can have those same 3 outcomes here. The first one we're going to actually do has a infinite number of solutions outcomes. So we'll be able to talk about how to tell the difference between these 2 answers, an infinite number of solutions and no solution, when you're doing these algebraically. So we are solving these algebraically. Okay. And again, this one's substitution. It's something you already know how to do. This section is very straightforward, but it's also going to be required when we do 4.6 and 4.7. So these ones are fairly easy, but don't blow them off because you're going to need them in depth when we get to 4.6 and 4.7 in this chapter later on. So they will be required again. It's not something that's going to go away. And actually, solving something algebraically is used all the way through any kind of math that you're ever going to take. If I have kids that this is their last math class, great. But if not, you go on to college and do some, I don't know, engineering or something else and take a lot of calculus, this comes into play quite a bit. So here's the first example that we're going to do. You're going to be given 2 equations, and they may be in slope-intercept form. They may not be. In this case, you have negative 9x plus 3y equals 21. And the other equation is y equals 3x plus 7. So this doesn't have to be in slope-intercept form. It can be in any other form. But your goal is to look for any variable that's already by itself. Because if you can find a variable that has no coefficient, you can stay away from fractions. So that's what this allows you to do. And the whole idea when you solve by substitution is to plug one equation into the other. Okay, so your goal, here's goal 1 right here. Use a variable with no coefficient. 2, you're going to plug one equation into the other, essentially, so you're either getting rid of the x or y variable, and solve for the remaining variable. Okay, so here we already have, if you look at the 2 equations at the top, we have negative 9x plus 3y equals 21. and y equals 3x plus 7. Well, my first thing I said here was to use a variable with no coefficient, and this has that. Y is already by itself. So what we're going to do in substitution is take part of the equation and plug it into the other one. So I'm going to put what's in this box right here. If y equals 3x plus 7, I'm going to put 3x plus 7 where this y is. Okay? So that's going to look like this. I'm going to rewrite down here, negative 9x plus 3y equals 21. And then I'm going to put 3x plus 7 in for the y variable. Okay, so I'm going to put what's right here. I'm going to put it right here. So this is going to look like this. This is the substitution part. So I'm going to put 3x plus 7. Now, what you're going to see happens here is when I distribute, I'm going to bring down this negative 9x. I'm going to distribute, and I'm going to get 9x plus 21. Well, what happens to the negative 9x and the positive 9x is these will cancel out, leaving me 21 equals 21. And when this happens, when these two numbers equal each other, that means you have an infinite number of solutions. $21 is always going to equal 21, right? Always. So this problem has an infinite number of solutions. Which, if you think back to the graph, that means that we would have had two lines that would have graphed directly on top of each other. Okay? If, this is an if, the variables cancel like they did up here, and those two numbers don't equal each other, then you have no solution. Okay, so if your answer had looked like you had negative 9x plus 9x plus 10 equals 21, and when you cancel these out, you end up with 10 equals 21. Well, that's not true. So you have no solution. Okay, that's what that would look like. Your variables would cancel, but the numbers wouldn't equal each other. So that hits two of our types of solutions. Now, let's talk about another problem. This one we'll have to work through all the way. So this is given, this is another example, x plus 3y equals 5, and negative 2x plus 6y equals 14. So remember, in the last slide, I mentioned that you want to look for, excuse me, you want to look for a variable with no coefficient. Right? You don't need to rewrite that. That's just me kind of stating that for you. And that happens in this first equation, right? This x has no coefficient. So what we want to do here is get the x by itself. And we can do that by moving the 3y away from it. So we're going to move the 3y, move a 3y, and we end up with x equals negative 3y plus 5. Okay, so what I'm going to do is plug this into the other equation where the x is. Okay, so this is going to look like negative 2, and then I'm going to, instead of the x, I'm going to put negative 3y plus 5. Oh, there's a y in there. Plus 5. And then I'm going to bring down the remainder of that equation. So plus 6y equals 14. And then you're going to solve. Okay, so this one we're going to distribute, combine like terms, keep on going. So I distribute. I get a positive 6y minus 10 plus another 6y equals 14. Here I'm going to combine like terms. 6y and 6y is 12y minus 10. I'm going to move the 10. 12y equals 24. And divide by 2, or 12, sorry. And y equals 2. Okay, so now when you get that solution, you need to plug it back in here to solve for the x variable. Okay, so you always have to have x equals and y equals. So now I'm going to go x equals negative 3 times 2 plus 5. X is negative 6 plus 5. X is negative 1. And so my answer to this, remember it's always an ordered pair, is negative 1 comma 2. And if you were doing these on paper, probably a check would be required. In Varsity, it will check for you. Okay, now I just want to make a statement. Those of you that don't have your sound on are probably going to pay a little bit. But in Varsity, for these problems, let's see, this is 4.2. From number 7 on, let me show you. So the beginning of these, it's going to say solve by substitution, substitute the expression, blah, 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 blah. So you're going to put the 3x plus 5 right here and solve, right? And you're going to get an ordered pair and go from there. When you get to question 7, it's simply going to say solve by substitution and determine how many solutions it has. Does it have 0, meaning it is no solution? Does it have 1, meaning you get an XY answer? Or is it infinite, like our first one? It is not enough for you to tell me what that answer is on your assignment. So I expect to see these problems worked out and see your answer. In order for you to get full credit on your completion, which is essentially you handing in your work, right? So if you don't have any work for these 7 through 12, or you've got them right on Varsity, but all I see is you have one answer, not good enough. I want to see you work these problems out. Show me what your actual answer is. So you should have some ordered pair, or you should have no solution, or you should have infinite number of solutions because of the work that you did. Okay, there's only 12 questions. Take the time, practice this, and work these out if you want full credit on that completion grade. Okay, I appreciate that. Thank you very much. So let's go back to here. And that's it. I'm not going to go through any other examples. If you need some help, we can go through those if we're in the classroom, or we can Skype or Zoom or do something. So, okay, toodaloo.